Okay, so this is just a quick rundown of the digital synth used in the listening test. So all the sounds are produced from this instrument that was exported as an application from Macs. Now, the one issue with apps exported from Macs is they're not well optimized. So objects like load bangs and load mess um, aren't working in the patch inside of Macs. It was no problem. You could open it up and everything would bang. But the issue is here you will just have to initialize every object to actually get it to start making sound. And you're going to have to just twiddle these knobs and the mix knob as well. So at the moment we're just listening to a free running oscillator, and it is a Gen Square. So that's the triply generated oscillators from the thesis. And then we'll just use the React, which is the anti-aliasing object that comes with Max. So we can sweep between the two, and you can see the difference in the content in the FFT here. You can see that the Gen Square has a lot of aliasing components and a lot of extra harmonics that are which are unmistakably digital artifacts, and then of course the React is nice and clean. So also we have the filters as well. So this is the FIR, which is a finite impulse response filter. It's a second order filter, similar to the second order filter that we built in the analog domain. And of course a couple of assumptions were made, but it's close emulation. So if we just play the sequence, and we can do a bit of cut off, let's add a bit of resonance. Then we can just mix between the two. And of course then every other oscillator that was discussed in the thesis is available here. So let's just stop that sequence for a second, and let's just draw a envelope. It's a kind of classic AVSR shape, like so. So if you had a MIDI keyboard, you could play this. So let's have a look at the additive saw versus, actually no, sorry, additive square versus React. I'm just gonna play that sequence again. So you can see in the additive square there's not that much harmonic content just because of the way it's generated. So it is every second harmonic from the fundamental. So if the fundamental was 1K, it'd be 3K, then 5K, and obviously amplitude dips off. But when compared to React, you can see all the extra harmonic content, which is attributed to its kind of timbre sound. Two same shapes doing the same thing sound completely different, and that was kind of a key part of the thesis. We just assumed that all these shapes look the same, however, because of the way they're generated, they don't. But anyway, let's just listen to this. Speed it up a little. Yeah, and that's that.